let's identify the line of best fit. So we're given 10 ordered pairs. We want to find the line of best fit to identify the slope and the y-intercept. Then we're going to find the correlation coefficient, and it's not labeled, but we're also going to talk about what does all of this mean. All right, so we don't know what these ordered pairs represent, but that's okay. So to find the line of best fit and to find the slope and y-intercept, the easiest way to do this is let's graph it. So if I highlight my two pieces, I'm going to go up to Insert and then check out the charts. Now, the line of best fit is generally a regression line through a scatter plot, right? So I'm going to go into this XY scatter and just give me a scatter plot. So you can see I have my X values, make it a little bigger here so we can see it. I've got my X values along the bottom and my Y values on the vertical axis here. Now, if I click on one of these points, they all highlight, and now I'm going to right click. Okay, so I have some options here, and you can see add trend line. So that's what I'm going to do. Boom, there's my line of best fit. I found it. If you go over to where it says format trend line, we're on the right side of the screen now, we can see that linear is tagged here, right? This is a linear trend line. If I go down, you can see display equation on chart, and go ahead and click display R squared value. All right, so we have both of those, and let's get rid of that. So now make this, wrong button, make this a little big. Why can I not make this bigger? Okay, so I'm just going to go in and we'll do it this way. Okay, so we see our slope. So I know that my slope is 0.323. That means for every, why did I do that twice? Okay. Remember, the slope is the change in y over the change in x. So for every increase in x, my y increases about 0.3223. Okay, so that's the y value over 1x. Now the y-intercept is negative 2.5323. So that means when x is 0, y value is negative 2.5. So if this line of best fit would be extrapolated, if we would take it and go all the way over here where the x is 0, down over here, it would be at negative 2.5 on the y-axis. So that's my starting point. Now, the correlation coefficient is what tells us if this line of best fit is a good fit for this data. And we know that the correlation coefficient is R. Well, we have R squared, right? So to find R from R squared, we need to take the square root of 0.9533. So if I type in equals SQ, so you can see we get square root, and I'm going to type in 0.9533. So my correlation coefficient, this is my correlation coefficient, is 0.9763708. And I know it's positive because if you look at my line, it goes up, right? It's like I'm climbing a mountain, that's positive. So my positive correlation coefficient of 0.9763708 tells me that this is very close to 1. That means my data is pretty linear. So my line of best fit is probably going to be a decent estimate if I would use it to predict future values. So the slope and y-intercept would, and the equation for the line of best fit would allow me to make estimates. So if I would say, well, what if x was 40? I could plug in 40 for x, solve, and that would give me an estimate output for y. So the closer R is to 1, the more faith we can have in the value of Y. Like we can say, it's probably a lot closer to accurate than, let's say, if R was 0.6, right? So the closer your R value is to 1, the more linear your data and possibly more accurate for your line of best fit. Thanks for playing.